Following statements regarding a unit dimensional stress system on the principal plane. Here in a unit dimensional stress system on the principal plane, the following are the stresses have some values. Here shear stress is 0, normal stress is 0, shear stress is maximum, normal stress is maximum. So here are the codes given below in the options 1 and 2 correct, 2 and 3, 1 and 4 and 3 and 4. So principal plane is a plane on which the normal stress is maximum and shear stress is 0. The principal plane is nothing but it is a plane which carries only normal stress without having shear stress. So that is nothing but it carries 0 shear stress and the maximum normal stress. And in the options 1 and 4 are correct, and in the given option C the right option. It accelerates uniformly from rest to 2000 rpm in 20 seconds. What is its angular acceleration? Here the options are 4.26 radians per second square, 6.43, 8.46 and 10.47. So coming to the solution, wheel starts from the rest. That means the initial speed of the wheel is equal to 0, or rotation of the wheel is equal to 0, so that the angular rotation also equal to 0. And the final speed of the and it reaches is a rotation of 2000 rpm. Let us say n1 is equal to 2000 rpm. At this moment the angular velocity is equal 2 pi n1 by 60 and is equal 209.5 radians per second square. So it reaches in 20 seconds. So the angular acceleration or the final angular velocity is equal to omega naught plus alpha into t. So here omega naught already 0 and alpha is equal to omega 1 by t and is equal 209.5 by 20 and is 10.47 radians per second square. So alpha equal 10.47 radians per second, and in the option the correct option is D. D is the right answer. Components in the x and y directions are given by u is equal to lambda x y cube minus x square y and v is equal to xy square minus 3 by 4 y power of 4 respectively. The value of lambda for a possible flow field is. Here the options are minus 3 by 4, minus 4 by 3, 4 by 3 and 3. Coming to the solution, for the possibility of the flow, the continuity equation must be satisfied by the flow field. So here the continuity equation for any flow is given by dou u by dou x plus dou v by dou v plus dou w by dou z is equal to 0. But it is a two-dimensional flow. Here w is equal to 0. The flow in the z direction is equal to 0. So that it must be satisfied dou u by dou x plus dou v by dou y is equal to 0. And we know that u is equal to lambda x y cube minus x square y, where dou u by dou x is equal to lambda y cube minus 2xy. And coming to the velocity in y direction, dou v by dou y is equal to 2xy minus 3y cube, and dou u by dou x plus dou v by dou y is equal to lambda y cube minus 2xy plus 2xy minus 3y cube is equal to 0. Here 2xy get cancelled, and here lambda is equal 3. So for the possibility of the flow field, the lambda should be equal to 3 to satisfy the continuity equation. So in the option, the correct option is D. D is the right answer. In a counterflow heat exchanger, specific heat capacities of hot and cold fluids are same. If N2 is equal to 1, effectiveness of heat exchanger is. Here the options are 3, 1.5, 0.75 and 0.5. Coming to solution, here the effectiveness of counterflow heat exchanger when the specific heat of both hot and cool fluids are same is equal to N2U by 1 plus N2U, where N2 is the number of transfer units and is given by 1, and it is equal to 1 by 1 plus 1 and is equal to 1 by 2. So here the right answer is 0.5, and in the option the correct option is D. D is the right answer. Ratio of atmospheric air at 28 degrees centigrade dry bulb temperature and 760 mm of Hg is 0.016 kg per kg of dry air. What is the partial pressure of water vapor? Here we know that the humidity ratio is equal to omega is equal to 0.622 PV by PB minus PV, where PV is the partial pressure of water vapor and PV is the atmospheric pressure, and here omega is given by 0.016 and PV is given by 760 mm of Hg, that is 0.016 is equal to 0.622 into PV by 760 minus PV. So from this equation we get here PV, that is equal to 12.16 divided by 0.638, and which is equal to a value of 19.06 mm of Hg. When we convert into Newton per meter square, 19.06 into 133.3 is equal to 2540.6 Newton per meter square. So in the option, the correct option is B. B is the right answer. So here 1 mm of Hg or 1 bar is given by 750 mm of Hg. Our atmospheric pressure 1.01325 bar is given by 760 mm of Hg. So from this relation we can convert this this pressure into Newton per meter square, and it has a value of 2540.6 Newton.